Right, we're working on intermediate algebra. This is section 2.3, starts on page 74 of your book. We're going to talk about solving systems of linear equations by elimination. Alright, so this is alternative method to graphing. Now, I know already you're thinking, well, if I've learned how to graph, why do I need to learn another method? We're actually going to learn even another method after this. We're going to learn substitution, because if you saw with graphing, we could not determine the actual ordered pair without a graphing calculator or without using elimination. It is required for this class that you learn all three methods, and you will be tested on all three. So example 1 says solve the system using elimination. So 7x plus 3y equals 4. 7/3 x plus y equals negative 5. Now, if we're using elimination, which we are because the directions say to use elimination, the first thing we have to recognize is we don't want our equations in y equals mx plus b. Instead, this time we want them in standard form. And standard form, not form, standard form for a linear equation is ax plus by equals c. Or in other words, the x term plus the y term is equal to the constant term, the x and the y on the left, the constant on the right. If you look at these two equations here for our system, they are in already standard form. Okay, so just a little bit of explanation of what elimination is. Elimination is the process of manipulating one or both of these equations so that I can add them vertically and eliminate one of the variables. To make one of the variables eliminate, the coefficients have to be opposites. In other words, one of them has to be positive, the other one has to be negative of the same number. Opposites would be positive 3 and negative 3, or positive 7 and negative 7, or positive 5 and negative 5. So we're going to manipulate these equations to make one of the variables eliminate. And it doesn't matter if I want to eliminate x or I want to eliminate y. Go for the one that's easiest. So how do you choose which one is easiest? Look at these coefficients. The easiest one to manipulate is the coefficient of 1. And then you look above it. All right, what's the opposite of positive 3 would be negative 3. How do I turn this 1 into a negative 3 so that when I add them, they make 0? Well, you're going to multiply. To turn a 1 into a negative 3, we have to multiply times negative 3. So we're going to multiply this entire second equation by negative 3. All right, so I'm just going to bring this first equation down. Let's scroll up just a teeny bit here. The first equation is 7x plus 3y equals 4. I'm not changing that equation at all. The second equation I'm manipulating so that it's the opposite here with the positive 3. And I'm going to multiply. This is distribute. I'm going to multiply through the entire equation by negative 3. When you distribute, everybody's freaking out right now because it's a fraction, but these two 3's will cancel because this is really 3 over 1. Okay? These two 3's will cancel each other. We have a negative 1 then times 7, which makes negative 7. And then negative 3 times 1 makes negative 3. Don't forget your variables. And then negative 3 times negative 5 makes positive 15. This is probably the most common mistake I see is students forgetting that when I manipulate an equation, this has to get multiplied over here also. So now the second part of elimination, first is setting up your equations, the second is the actual addition. Now this is a special equation because when I do this addition, I'm going to add straight down. Well, 7x plus negative 7x gives me 0. The x's are gone. And 3x plus negative 3y plus negative 3y also gives me 0. Well, this is what I wanted to be 0, but I did not know in the process that this would also be 0. So this is a 0 here. when I add this, I get 19. All right, so basically this is a statement that says 0 equals 19. Well, I don't know if you guys remember this from a couple sections back. We looked at that chart that said when you get a false statement like this, 0 does not equal 19. 0 can never equal 19. This does not mean that x equals 0 and y equals 19. The x and the y are gone. When you get a false statement like this means there are no solutions. And we know this from the last section that when there are no solutions, that means that these two lines are parallel. And this is your answer here for this system. There are no solution, these lines are parallel. All right, example 2 is on page 75. It says solve using elimination. So my two equations are 2x equals negative 5y plus 1, negative 10y equals 4x minus 2. All right, the first thing you need with elimination is you need your equations in standard form. ax plus by equals c. Neither one of these equations are in that form. So we're going to take this first one down here, and we're going to put it in standard form. Standard form has the x term plus the y term on the left, the constant term on the right. So that means this y term needs to go over here, and of course when I move this over here it will change now to a positive. So that'd be 2x plus 5y equals 1. The second equation says negative 10y equals 4x minus 2. To get it in standard form, the x and the y term both need to be on the left, so this x term needs to go way over here in front of the y term. And when I move it over there, it's going to become a negative 4x. So that'll be negative 4x minus 10y equals negative 2. And now these are my two equations. To use elimination on them, I need to compare the coefficients. I have a 2 here and a negative 4 here. I have a 5 and a negative 10. I need them to be opposites. This either needs to be 2 and negative 2, or 4 and negative 4, or 5, negative 5, 10, negative 10. Now, to manipulate these, I'm going to use multiplication. I cannot make a bigger coefficient into a smaller coefficient with multiplication. I can only make the smaller into the bigger. So I can make this 2 into a negative 4 or a positive 4. I need a positive 4 to eliminate with that one really easily, just by multiplying by times 2. I can also make this 5 into a positive 10, and it doesn't matter which one you choose to do. Let's eliminate x. Let's multiply this entire equation by positive 2, and that's going to turn it into 4x plus 10y equals 2, because this 2 just distributes then. And then I'm going to bring this one, I'm going to put it underneath here. Negative 4x minus 10y equals negative 2. And I don't know if you noticed, but this is a similar situation to the one we had on the last example. When I get ready to add these straight down, these x's are going to eliminate, and that's 0. But the y's are also going to eliminate. So again, I have 0 plus 0. What happens over here now, when I add these constants though, I also have 0. 2 plus negative 2 equals 0. So in effect, I have 0 equals 0. Similar to example 1, except example 1 said 0 equals 19. This is a true statement. 0 does equal 0. So when you get a true statement, it doesn't mean no solutions. A true statement means there are infinitely many solutions. That's an S. There are infinitely many solutions, which means that these are the same line. So when you get a false statement at the bottom here, like we had 0 equals 19, there are no solutions. The lines are parallel. But if you get a true statement, and this could be 0 equals 0, 5 equals 5, 12 equals 12, 1 equals 1. If it's the same on both sides, then there are infinitely many solutions because these are the same line. Okay, example 3 on page 75 says solve using elimination, and the equations are negative 5x plus 3y equals negative 12, and x plus 7y equals 10. First off, to use elimination, we have to have our equations in standard form. Ax plus by equals c. So this first equation says negative 5x plus 3y equals negative 12. All right, this is already standard form. The second equation, x plus 7y equals 10. All right, these are already in standard form. So I need to manipulate because I have to have opposites. It's going to be difficult for me to get these two numbers. I can't turn a 3 into a 7 easily unless I use fractions, which I know you guys don't want to do. So always look for the coefficient of 1. It's the easiest one to manipulate. So what do I really want this to be? I really want this, since this is a negative 5, I want this to be a positive 5. How do I get this to be positive 5? I multiply the entire equation by 5. And that's going to be distribute, and that's going to turn into then 5x plus 35y equals 50. And now I'm ready to eliminate. Those turn into 0. Negative 5x plus 5x, that's what you wanted to do. These now turn into 38y equals, this is a negative 12 and a positive 50, so this is going to be also 38. Now this is different from the last two equations because x and y did not both eliminate, only x eliminated. We still have y left here. So your next job here is to isolate this y. So dividing by 38 gives you y equals 1. If you get down to the bottom with a variable, y or x, this is telling you that there is a solution. So there's one solution here, which means the lines intersect and you already have the y coordinate here is 1. If you had an x here, you would have the x coordinate, but this is the y coordinate. The y coordinate is 1. Now, we still need an x coordinate. So we're going to go back to one of these. Doesn't matter which one. I'm going to use this one just because it's lower numbers. And we're going to substitute our y in there and solve for x. So let's write that equation here. X plus 7y equals 10. We're going to substitute a y of 1 here. So that's going to say x plus 7 times 1 equals 10, which is of course 7. Isolate x. We get x equals 3, and that will be your x coordinate here. Okay, example 4 on the top of page 76, still solving using elimination, says negative 5x plus 3y equals 55, 7x plus y equals 1. The first thing we look for is are the equations both in standard form? And yes, they are. X plus y equals a constant. What can we manipulate to make a variable eliminate? This is going to be difficult, but this one here I could turn into negative 3. Negative 3 will eliminate with positive 3. To do that, I need to multiply my entire equation by negative 3, and that's going to be a distribute. So let's just bring down this first equation, negative 5x plus 3y equals 55. The second equation is going to turn into negative 21x minus 3y equals negative 3. Now these y's eliminate. One thing I do want to mention, because I see a lot of mistakes here, when you do this elimination, make sure these signs are opposite. If they are the same sign, they do not eliminate. They have to be one positive and one negative. Doesn't matter which order they're in, but they have to be opposite signs to actually eliminate. All right, this turns into negative 26x, and this is an equal to 52. So we now have an x variable that we can isolate here just by dividing by negative 26. Gives us x equals negative 2. So that's telling us, since we have an x value, that there's one solution. These lines intersect. And we know the x coordinate is negative 2, we just don't know the y coordinate yet. We're going to use our original equations to find the y coordinate. It doesn't matter which one you decide to use. I use the one with a lower number, so that would probably be the second one. 7x plus y equals 1. I'm going to carry it down here. (7x plus y equals 1). Then I'm going to put x in here and solve for y. So that's going to be 7 times negative 2 plus y equals 1. Negative 14 plus y equals 1. We need to add this 14. We get y equals 15. And that will be your y coordinate there. All right, example 5 is page 77. Solve using elimination. 2x plus 3y equals 9. 5x plus 4y equals 5. The first thing, are the equations in standard form? And yes, they are. We have x plus y equals a constant. The second thing, which one can we manipulate to make them eliminate? And there aren't any coefficients of 1. A coefficient of 1 is the easiest one to eliminate. So now we got to think about, okay, I'm going to have to do something a little bit more. I can't make a 2 turn into a 5, and I can't make a 3 turn into a 4 without using complicated fractions. So instead, I'm going to either turn both of these into a number that I can multiply to get them both, or the least common multiple. And the least common multiple of 2 and 5 is 10. I could turn both of these to 10. Or I could turn both of these to 12, the least common multiple. It just is going to involve manipulating both equations. And I think I'm going to go for the 10 here. All right, so to turn this first equation into a coefficient of 10 here, I have to multiply this equation by 5. That means below it, the second equation, I don't want it to be 10, I want it to be negative 10. If this one's positive 10, this one needs to be negative 10. So to turn this to a negative 10, I need to multiply by negative 2. And I'm going to distribute this 5 up here. That's going to give me 10x plus 15y equals 45. I'm going to distribute this negative 2 down here. That's going to give me negative 10x minus 8y equals negative 10. And then I'm going to add. These eliminate. Again, checking to make sure I have opposite signs here. When I add these, I get 7y equals 35. Divide by 7 to isolate y, you get y equals 5. That tells you about the solutions. There is one solution. And that means about the lines that the lines intersect. And we're going to find where. We know the y coordinate is 5. To find the x coordinate, we're going to go back to our original equations up here. Here's our original equations. You can use either one. I'm going to use the top one. 2x plus 3y equals 9. I'm going to write it down here. 2x plus 3y equals 9. I need to find this x coordinate, so I'm going to substitute this y right in here. So that gives us 2x plus 3 times 5 equals 9. 2x plus 15 equals 9. Subtract that 15, and we get 2x equals negative 6. Divide by 2. X equals negative 3. So that's the rest of our ordered pair there. All right, I'm going to stop here. There are 3 word problems for the rest of this section. I'm going to do those on a separate video because it feels like this one's getting kind of long. So go to the next video for example 6, 7, and 8.